Beneath the peaceful exterior of the moon, strange things are happening. Although it might look calm, there's a hidden world of movement and mystery beneath the surface. Moonquakes, which are like lunar earthquakes, have baffled scientists for a long time. Humans caused them during the Apollo missions, and the echoes of those events still shake the moon today. Join us on a thrilling adventure as we uncover the truth behind these puzzling moonquakes and explore the moon's secrets. Back in the fascinating year of 1969, during the Apollo 12 mission, astronauts Pete Conrad and Alan Bean set their lunar module down in a region called the Ocean of Storms on the moon's surface. Part of their mission involved deploying an intriguing payload called the Apollo Lunar Surface Experiment Package. It contained a bunch of scientific gadgets, one of which was a remote seismic monitoring station, something we usually use to detect earthquakes here on Earth. After their moonwalk, and when they headed back to their command module, they intentionally crashed their lunar ascent stage back onto the moon's surface. This crash caused a significant seismic event, like a lunar earthquake. It hit the moon with a force equivalent to about 1 ton of TNT, and the seismic monitoring station recorded the ensuing shockwave. Interestingly, it took 8 minutes for this moonquake to reach its peak, and then an additional hour for the tremors to completely fade away. A similar lunar shakeup occurred during the ill-fated Apollo 13 mission. While they didn't manage to land on the moon due to a technical glitch en route, they did accomplish something intriguing. The third stage of the Saturn V rocket, known as the SIVB, was intentionally sent crashing into the moon. The SIVB was a substantial hydrogen propulsion stage, much bigger and heavier than the lunar ascent vehicle. When it slammed into the moon, it generated a whopping force, equivalent to 11.5 tons of TNT, creating shock waves that were 30 times more powerful and 4 times longer lasting than the Apollo 12 impact. What's captivating is that in both these experiments, the vibrations recorded by the remote seismic station lasted much longer than scientists had initially expected. These vibrations on the moon far outlasted any similar vibrations recorded on Earth. This phenomenon led some NASA officials to describe the moon as ringing like a bell, a phrase that gave rise to a peculiar and fringe conspiracy theory known as the hollow moon. Some believers think that since the moon rang like a bell and bells are hollow, then the moon must be hollow too. However, this idea is not grounded in scientific reality. First, an object doesn't have to be hollow to vibrate or produce ringing sounds. Musical instruments like the glockenspiel and xylophone use solid materials to create bell-like tones. Second, the moon isn't hollow. It's a solid celestial body. The actual reason behind the moon's bell-like resonance is much more intriguing, and we'll dive into that in just a moment. Now let's delve into some of the natural lunar tremors that occur without any help from humans crashing things into the moon. Those Apollo lunar surface experiment packages, which were carefully positioned on the lunar surface between 1969 and 1972, continued to operate and collect data for several years until they were remotely switched off in 1977. During that time, NASA gathered a treasure trove of information about the moon's natural seismic activity. This data is quite intriguing because it helps us understand lunar quakes, which are fundamentally different from earthquakes on Earth. You see, earthquakes are caused by the movement of tectonic plates that make up the Earth's surface. However, the moon doesn't have tectonic plates. Its surface is a single continuous shell. So what gives rise to moonquakes? One well-known type of lunar activity is the thermal quake. This one is relatively easy to grasp. Picture this. Each half of the moon goes through a cycle of 14 days of unrelenting sunlight followed by 14 days of absolute darkness. Because the moon lacks an atmosphere to insulate its surface and maintain a stable temperature, the lunar surface temperature swings wildly. It can soar to a scorching 250 degrees Fahrenheit during the daylight periods and plummet to a chilling negative 208 degrees Fahrenheit during the nighttime periods. Now, here's the fascinating part. Just like any solid material subjected to such drastic temperature fluctuations, the moon's surface expands and contracts as it shifts between day and night. This constant expansion and contraction lead to significant vibrations that ripple through the moon's surface, creating what we know as moonquakes. It's a captivating dance of temperature-induced quivers happening right beneath our cosmic neighbor's serene exterior. But that's not the whole story. There's more to uncover about these lunar mysteries. Another intriguing source of seismic activity on the moon is the so-called tidal moonquake. You see, on Earth, we feel the moon's gravitational force as it causes the ocean tides to ebb and flow. Similarly, the Earth's gravity exerts its influence on the moon, tugging and stretching its surface material. This gravitational interaction isn't one-sided. It also stirs up some residual seismic activity on the moon. It's a celestial back and forth that results in these intriguing lunar quakes. Moreover, the moon experiences a fairly high frequency of natural impacts. Besides us, humans tossing spacecraft parts its way, the moon regularly faces collisions with asteroids of various sizes, ranging from tiny micrometeorites to hefty metal boulders. Each of these cosmic impacts leaves behind a seismic footprint, further contributing to the moon's shivers. All this lunar seismic activity, both human-induced and natural, was meticulously documented thanks to the scientific instruments left behind by the Apollo missions. By Apollo 17, the final crewed lunar mission, we had deployed the most advanced equipment, including a payload known as the Lunar Seismic Profiling Experiment. Back then, this was cutting-edge research. However, it was the 1970s, and communication between the lunar instruments and Earth-based receivers was relatively low bandwidth by modern standards. Fast forward to 2023, and scientists at the California Institute of Technology made a remarkable breakthrough. They discovered a way to extract even more detail from the Lunar Seismic Profiling Experiment data using artificial intelligence and machine learning algorithms. These cutting-edge technologies allowed them to fill in the missing pieces of the seismic recordings, effectively enhancing our understanding of the moon's seismic activity and uncovering previously hidden details. It's like uncovering lost pages of an ancient cosmic diary, shedding new light on the moon's enigmatic quivers. Amid the quest to differentiate naturally occurring moonquakes from external influences, scientists stumbled upon an astounding revelation. The Apollo 17 lunar lander, positioned a mere 100 meters away from the seismic measuring equipment, was in fact generating moonquakes on its own. It may sound surreal, but here's the explanation. Over the years, this lunar lander experienced the unrelenting lunar day and night cycle, which involves extreme temperature swings. The result? The metal structure of the lander expanded and contracted due to these temperature fluctuations. This seemingly subtle movement of the metal over the moon's surface was sufficient to set off vibrations that traveled through the lunar ground and reached the monitoring equipment. To clarify, these were incredibly subtle tremors. If you were standing on the moon next to the lander, you wouldn't actually perceive the vibrations. Yet, they were discernible enough in the 50-year-old data recordings to demonstrate that the moon's surface is a remarkably effective conductor of vibrations, even extremely minor ones. Now, here's the million-dollar question. Does this newfound discovery bolster the credibility of the hollow moon theory? In essence, could the moon be extraordinarily resonant without being a hollow bell? To answer this, let's take a brief detour and consider the xylophone. The keys of this musical instrument are typically made from blocks of wood specifically chosen for their capacity to produce distinct pitches. Not any wood will do. Only thoroughly dried hardwood varieties can vibrate freely enough to create musical notes. Soggy, soft wood would dampen the vibrations before they could resonate effectively. Now ponder Earth's surface. It's covered with a lot of water. The more moisture there is in the surface materials, the less dense their structure. This damp material acts like a sponge, absorbing and deadening the vibrations produced by an earthquake, which helps to confine the most severe effects to a localized area. But when we shift our focus to the moon, a stark contrast emerges. It's devoid of moisture. It's incredibly dry. The entire lunar crust consists of a single, continuous, cold, and rigid structure. So, even if a moonquake might be less intense than an earthquake, there's nothing to dampen these vibrations on the moon. They persist, reverberating back and forth through the lunar body, akin to a ringing bell until the solid stone eventually quells them. So, while the moon may not be hollow, it's unquestionably a peculiar celestial body, at least by Earth standards. This peculiarity raises a critical point to consider as we look toward the future of lunar settlement and colonization. Mining and extended construction on the moon are part of NASA's Artemis program's eventual goals. China and its allies are also eyeing a permanent lunar base. However, we must confront a critical question. How will this substantial increase in surface activity affect the lunar environment? If a relatively small lunar lander, merely shifting back and forth over a few millimeters of lunar surface as it expands and contracts with temperature changes, can generate detectable vibrations, What will large-scale mining operations or frequent landings and takeoffs of substantial vehicles like SpaceX's Starship do? The truth is, a colonized moon is likely to enter a constant state of seismic activity, a permanent moonquake, on top of the naturally occurring moonquakes. This presents one of the numerous challenges that humanity must navigate on its arduous journey towards becoming a multiplanetary civilization. As we continue our exploration of the cosmos, each celestial body, from the moon to Mars and beyond, will unveil its unique intricacies, and will need to adapt and innovate in response to these cosmic surprises. So, what are your thoughts about moonquakes?
Share with us in the comments below. And if you enjoyed this video, show us some love by hitting that like button and leaving a comment down below. Also, if you're a fan of all things technology, be sure to check out this other video we've got lined up for you. It's packed with all the latest news, tips, and tricks to keep you ahead of the curve.